and let's get our next guest on here. Oh, we're getting a fax.
We're getting a fax.
Rita's had Stefan join us.
We'll read the facts on the next break.
Yeah, we're gonna talk to Stefan now. How's it going, Stefan?
Hello, Oli. Hello, Sid. Hello, everyone. I'm here to talk about the BrailleRap project, which is an open source Braille embosser, and maybe we can introduce what is Braille. Braille was imagined in 1825 by a French guy, Louis Braille. What is important is that it's an alphabet. You know, you are just coding later in tactile manner that you can sense with the finger. And because the question will arrive soon, there is a limited number of combinations in a cell because you just have 6 dots. And each country has modified the original Braille to adapt its usage. Even in French and in English, you have some change. For standard alphabet letters, it's okay. When you are using capitals, there is some change. It's not the same. Making Braille documents for unsighted people. It's a large subject in the makers and open source movement. We can remember some interesting projects. Maybe the most famous is BrailleGo, a teenager who made the first Braille embosser with just Lego. And Carlos Campos Open Braille, who won the Academy Prize a few years ago. Many projects try to produce Braille documents. Many of these projects were very proof of concept, but hard to reproduce because they are starting about recycling some stuff or making some very specialized things. In 2016, My Human Kit, which is a French non-profit organization, start to do some tests in a hackathon just by modifying a 3D printer, putting a nail above the printer head, and try to write a piece of software to translate text into Braille and the Braille into G-code, just to drive the printer and make some dots on paper. All these projects were working, but they were hard to reproduce and not very user-friendly. So with Philip Packott, we decided to make a new design just to build the Braille embosser project, which will be open source, easy to build in the Fab Lab, and with widely available parts. And the first things we try to do is making Braille dots. So as all other projects use motor to pinch a Braille stylus on paper, we just decide to use a solenoid because solenoids are very strong, they are very fast compared to motor, and they are cheap, and they are also very easy to operate. You know, you just have to put the current and they put the pressure. So we just put a braille stylus at the end of a solenoid, and it appears that pinching the paper between a stylus and an anvil, it worked incredibly well. Everyone say that the braille is of wonderful quality. Once you have a tool to emboss braille dots, you just need to move the tool in the X or Y axis on the paper. And this is a very standard design for for a CNC machine. So you just passing the paper through a carriage on the top and a carriage on the bottom. The two carriages are synchronized, and you can put some dots on paper. And this is what it is. A BrailleRap, it's a numerical control machine with specialized tools to emboss braille dots, like a BrailleRap. You see the analogy with the name. But instead of a head to put some melted plastic, you just use a tool to emboss dots. You can actually do the frame with plywood or some transparent PMMA, some 3D printed parts, and some tools taken from a standard 3D printer, some gear, the steppers motor, things like that, and a 3D printer controller board with just a slightly customized Marlin frame firmware. And just because designing a machine is not just a one step, we make many iterations. On the left, you see the first, maybe the prototype of BrailleRap 0, and you have the 6th version on the right. The main problem we address is to handling the paper on the machine, because it seems very easy, but paper is very strange. In some situation, if you ply it, it's incredibly strong, and you can lock a motor with just a single piece of paper. What we conclude is that you don't have to force a paper. You just try to let him go where he wants to go, and everything will be fine. And maybe it's time to show you what is a BrailleRap. If you haven't seen a BrailleRap, here it is. So maybe we can go back to the presentation. Yes. Once you have a device that can load a sheet of paper, detect the edge of the sheet, the problem is the software. At the start of the project, we just write something. We can make basic translation. The translation was only in French, and in fact, Braille is really simple when you have just a letter. But when you want to mix some punctuation, some number, some capital letters, you have some strange rules, and it's not so easy. We try a second open source software, which is called NetBraille, which is a French project. We realized, yeah, voilà. A very good Braille translation, but in French. In fact, what is interesting is that the G-code aspect was hidden to the user, so you just have a print button and not generating G-code file using things like the Pronterface or Cura to send the file to the BrailleRap. So it was a nice improvement. But in fact, an evolution is in the Java license put some mess, and we had some compatibility issue with many Windows PC. So we started to develop our own software, and in 2023 we released the first version of Access BrailleRap. Access BrailleRap uses an open source library which is called Libri, and Libri is able to translate text to Braille in 2000 Braille standard. So you can use the software with French, of course, English, Chinese, Swahili, Vietnamese, what you want. And the most important aspect is that Access BrailleRap is accessible with NVIDIA screen readers, which is the kind of tools that unsighted people use to use a PC. And we talk it briefly, but BrailleRap is made basically from a 3D printer. So we can make dots on the paper where we want. So in 2024, we release desktop BrailleRap. And with desktop BrailleRap, you can mix some SVG graphics. You can see the Eiffel Towers, and mix it with some text, which is translated automatically into Braille. So you can produce some title document that showing some drawings, as you can see on the right. And actually, since 2018 and nearly the first version were just put on GitHub just to see what happened. And maybe a month later, a guy from India sent us an email and said, hey, I've started to make a BrailleRap. How do you do that things? And things like that, there is more than 50 BrailleRap all over the world. We made some action in some country, BrailleRap Cameroon in 2023. A guy, Sachinoy, made one in Fab 23 in Bhutan. BrailleRap also win a prize in the last Academy Prize in 2023. We made some operation in the Republic Democratic of Congo. And what is interesting is that where we made some workshop building BrailleRap, FabLab start to reproduce the workshop and build their own BrailleRap. We came in Cameroon in 2023, and they made 5 BrailleRap this summer. So it's a good solution. And the main reason is that the documentation and the assembly guide is publicly available with an open source license. It's a never-ending story, you know. We just have to work on it after each workshop to correct what you imagine and what people in workshop imagine. It sometimes a little step, and we ended with 160 page of step-by-step assembly because there is with the world that build a BrailleRap. I haven't even met them. And the second lesson is that using 3D rendering in the assembly guide is far better than photography or image, because you can just show what you want to show in the image, and it's easier to move from version to version when you do some modification. And now that we have a device, a working device, everybody is telling us that the sensation of braille is very good on paper. You can also use some different material. We try some plastics, even some metallic sheets. If you try to emboss some thin foil of aluminum, nearly 1/10 of a millimeter to 5/10 of a millimeter, you can use it to emboss braille. And you can do some stuff like the picture you see. It's an ultrasound. Just imagine when you are a couple of future parents, and one of the future parent is unsighted. How can you discuss with medical staff on the just a standard ultrasound? This is a project built over BrailleRap by the INRIA. They just put some image processing behind the ultrasound device, translate just the interesting region. You have the baby, the umbilic, the uterus, and you can render it directly with desktop BrailleRap, and in a few minutes you can have a tangible document made just on BrailleRap. And that has the question. BrailleRap obviously is a solution for a small organization or individual. It's open source. You can make one for yourself or for someone of your family. You can make one for a small organization. Obviously, you won't make 1,000 pages of braille with BrailleRap, because it's a slow device compared to what exists on the market. But it's accessible, you know. Build a BrailleRap will cost you around $300 or $400. The first commercial braille embosser on market is $2,000. And more widely, the question I love with the project is what can open source can do for inclusion. Because sometimes you need some very basic stuff, just put a smartphone charger on a wheelchair, open a door, taking a pen, a knife, and it's some kind of stuff that we can easily do with open source in FabLab. Just talking about open source, a little word about all the people that were involved in the project. Sometimes for just a tiny things, sometimes for Braille translation. There are nearly 2,000 contributors here for a part of mechanics, for a part of software. And it's again the opportunity to thank them. And of course, because we are in the OSHWA, BrailleRap is certified since this summer. So it's good things to have a list, catalog of open source device available around the stuff. And the presentation has go very fast. Thank you for your attention. I have some information if you want to go further on the device. The website himself, where you will find the documentation, all the software, and the GitHub link, and even the link to Instagram, and some video on YouTube.
Thank you so much, Stefan. It was so great to get a little update on the BrailleRap. We got to play with it a lot this summer. We were very lucky, and it's such a great device. It's really cool to see accessibility becoming such a priority within the open source community, especially. It's something we're both very passionate about. So thank you for all the work you do and for coming on today to talk to us about it.
And we'll make sure those links get into the chat and onto the socials so everyone else can check out the project too. Thank you.